So let's apply all the different rules of exponents that we just learned and take a look at a few more examples. So in this first example, we're going to simplify the following expression and then write our final answer with positive exponents only. So to simplify this, the first thing that we have to do is take care of this -3 exponent. So we're going to apply the power rule and apply that -3 power to every single term inside parentheses. So that gives us 2 to the -3 power times u to the -3 power times v to the -2 times -3. So again, here I am applying the power rule. Okay. All right. So 2 to the -3, if we use the negative rule of exponent, we can rewrite that as 1 over 2 to the third power. And the same thing here, u to the -3 is 1 over u to the third power. And then v to the -2, let's just rewrite that. That's v to the +6 power. And you can write that over 1 if you want to. Okay. All right. So this gives us final answer, v to the 6th power over 2 to the third power. We know that that's 8. So that 8 times u to the third power. And we've got positive exponents. Okay. Let's take a look at one more example. Let's simplify x to the 8th times x to the -12 times x. So here, let's rewrite x to the -12th using the negative exponent rule. So x to the 8th times 1 over x to the 12th power times x. And you can rewrite these terms here as a fraction by simply putting it over 1. And so in the numerator, I've got x to the 8th power plus 1. So you can think of that as x to the first power. So I'm applying the product rule there in the numerator. And then in the denominator, we've got x to the 12th power. So in the numerator, that's x to the 9th. The denominator, x to the 12th. And then here we can apply the quotient rule. So that's the same thing as x raised to the 9 minus 12, which gives us x to the -3. And then here, if we want to rewrite this using positive exponents, we're going to use the negative exponent rule. So we can rewrite this as 1 over x to the third power. Okay, one more example. So let's look at one last example. Here we want to simplify the expression using only positive exponents. So first thing that we're going to do here is apply the power rule. So we're going to apply the power rule by raising 2 to the 4th power, h to the 2nd power times 4, and then k to the 4th power. And then in the denominator, we're going to do the same thing. We're going to apply the power rule and apply that 2nd power to every single term inside parentheses. So let's go ahead and write that down and see what that looks like. This gives us 2 to the 4th power times h to the 2 times 4 power times k to the, you can think of that as to the first power times 4. And then in the denominator, we have 7 squared times h to the -1 times 2 times k squared times 2. Okay, let's go ahead and work this out. 2 to the 4th power is 16, and then h to the 2 times 4 is 8, and then k 1 times 4 is just 4. In the denominator, we get 7 squared, which is 49, times h to the -2 times k to the 4th power. Now, 16 over 49, I can't really simplify that any further, so I'm just going to write that as 16/49. And then now let's take a look at this term right here. We can use the quotient rule since we have a common base of h. So that gives us h to the 8 minus -2. And then let's take a look at this last term. So k to the 4th divided by k to the 4th, that cancels each other out and it just equals 1. So you can think of that as times 1. Or you can rewrite all this as a fraction. So you can write this as over 1, and then this is 1 over 1. So let's go ahead and simplify this part of the expression. So again, I've got 16 times h to the 8, right, minus -2. That gives us h to the 10th power times 1. And this is all over, so 49 times 1 times 1, let's just write that as 49. So we can simplify this as 16 times h to the 10th power over 49, and we've got all positive exponents.